Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on beta function type 3. In type 3, our formula of beta function is integration of 0 to infinity sine theta the whole raised to m into cos theta the whole raised to n dt is equivalent to half beta of m plus 1 upon 2 comma n plus 1 upon 2. So we have to make our given equation in this form so that we can apply the properties of beta. So this is our question. We have to prove that this integration is equal to this term. So if you see, we have two integration. One is this and one is this. So let's say this is I1 and this is I2. So we have I1 equal to integration of 0 to pi by 2 sine theta the whole raised to m into d theta. So in this we only have sine term, but we do not have any cos term. But in formula of beta we also require cos term, so we will assume that cos theta is nothing but cos theta whole raised to 0. So instead of this term we can write sine theta the whole raised to m into cos theta the whole raised to 0. So now if you compare these two equations are similar, then this term is equal to half beta of m plus 1 upon 2. Here also we have m, so m plus 1 upon 2 comma n plus 1 upon 2. In this case n is 0, so 0 plus 1 upon 2. This is equivalent to half beta of m plus 1 upon 2 comma half. So this is our I1. Now we will solve for I2. In I2 also we have only sine term, so we will write cos term with power 0, so cos theta the whole raised to 0. Now if you compare this equation with this equation, we have this will be m dash and this will be n dash. Then we have m dash equal to m plus 1 and n dash is 0, so n dash is 0. Then this whole term is nothing but half of beta m plus 1 upon 2. In our case m dash is m plus 1, so m plus 1 upon 2 comma n dash is 0, so 0 plus 1 upon 2, which is equivalent to half beta of m plus 2 upon 2 comma half. Now we will write this I1 in this equation and I2 also in this equation. We get I equal to I1 into I2. I1 is half beta of m plus 1 upon 2 comma half into half beta of m plus 2 upon 2 comma half. So this half and this half will become 1 upon 4. And for beta of m comma n we have direct formula, that is beta of m comma n is nothing but gamma of m into gamma of n upon gamma of m plus n. So we are going to use this formula, which is gamma of m plus 1 upon 2 into gamma of half upon gamma of addition of these two terms, which is m plus 1 upon 2, into same formula we are going to use for this beta. We get gamma of m plus 2 upon 2 into gamma of half upon gamma of addition of these two terms, which will be m plus 2 plus 1 upon 2. So we get 1 upon 4. These terms will remain as it is. Gamma of 1 plus 1 upon 2 is equal to m plus 2 upon 2 into numerator will remain as it is, and the denominator will be m plus 2 plus 1 is nothing but m plus 3 upon 2. So now this term and this term are equal, so we can cancel these two terms and we get 1 by 4 gamma of m plus 1 upon 2, and gamma of half is nothing but root pi, so this gamma of half will also be root pi. Root pi and root pi will become pi upon gamma of m plus 3 upon 2. So now we will keep the numerator as it is, and for the denominator we will use the formula gamma of n is equal to n minus 1 into gamma of n minus 1. So in our case n is m plus 3 upon 2. So gamma of m plus 3 upon 2 is nothing but m plus 3 upon 2 minus 1 into gamma of m plus 3 upon 2 minus 1. So when we take this 2 here, we will get m plus 3 minus 2, which is nothing but m plus 1 upon 2 gamma of m plus 1 upon 2. So instead of gamma of m plus 3 upon 2, we are going to write this term. So we get 1 upon 4 gamma of m plus 1 upon 2 pi, and gamma of m plus 3 upon 2 is nothing but m plus 1 upon 2 gamma of m plus 1 upon 2. So now this m plus 1 upon 2 will get cancelled, and we get pi upon 2 ones are 2, 2 twos are 4. So in the denominator we have 2 into m plus 1. So now if you compare this term with the given equation, both the terms are equal. So left hand side is equivalent to right hand side, hence proved. So this is how we solve the problem on beta function type 3. More such problems we will see in our next video. So stay tuned for our future lectures.